Hello friends, in this video we will show that even if there is no jump or gap in the graph or no abrupt rise or fall, still the limit at a point may not exist. And in order to see that, let us consider a function here. Let us take a function f of x equals sine of 1 upon x, where we will take x's in R represent the set of real numbers and x not equal to 0. We shall examine limit of x goes to 0 positive fx and limit x goes to 0 negative fx. Please note that this function fx is not defined at 0, x is not equal to 0, but it is defined in every neighborhood of 0, so that we can talk of the left hand limit and the right hand limit of f at 0. So before finding out what will be the right hand limit and the left hand limit of f at 0, let us draw the graph of sine x. So here is sine x. Let's draw the graph of sine x, which will help us to find these two limits. So here is the coordinate system. This is the coordinate system. This is x-axis. This here y-axis. We know that sine x goes like this. It is 0 at 0. It is 1 at pi by 2. It goes down. It is 0 at 2 pi by 2, that is pi. Minus 1 at 3 pi by 2. And like this. This is the graph of sine x on the right hand side. Now from left it goes in the same way. It's just like this. This is minus 6 pi by 2 here. And this sine x graph will help us to find this this right hand limit and the left hand limit. So in order to do this, we will have a table just like we were having in the first three lectures in the limit of function part 1, 2nd and 3rd. So here is the table. In the table, we have from the left, from the right, just like we were having in the previous videos. We will do the right part first, the right hand side part first. This is the x and this is f of x. Here we will be taking the values, x's which are close to 0 but to the right of 0, and we will be noting the function values at those points. The first point we shall take is 2 by pi. We see that if we look at f of 2 by pi, that will be same as sine of 1 upon 2 by pi, and that is same as sine of pi by 2, that is equal to 1. So f of 2 by pi is equal to 1. Similarly, if we take 2 upon 2 pi, but note that 2 by pi is just 2 upon 22 by 7, that is same as 14 by 22, which is less than 1 and hence close to 0. So the next point we shall be taking is 2 by 2 pi. If we look at sine of 2 by 2 pi, let me first rub out this. If we look at sine of 1 upon 2 pi, that is just same as sine of phi, and that is equal to 0. So this is equal to 0. Similarly, we can take 2 by 3 pi, and the value of f at this point will be equal to minus 1, because we see that sine of 3 pi by 2 is here minus 1, and sine of 1 upon 2 by 3 pi is same as sine of 3 pi by 2, which is minus 1. Similarly, we can take the next point as 3 by 4 pi, and that will be equal to 0. Similarly, 2 by 5 pi, and that's equal to 2 by 5 pi will be just 5 pi by 2 sine value, and that is 1. Similarly, 2 by 6 pi, which will be equal to 0, and 2 by 7 pi, which will be equal to minus 1. So these are the values of the function f(x) at points which are close to 0 but to the right of 0. Now from this side we shall be taking the points x's and the values at those points of f, but these points we shall be taking which are to the left of 0. As the first point we shall be taking 2 by minus 2 by pi. If we look at sine of minus 2 by pi, here it is minus 1. Next point is minus 2 by 2 pi. It will be just 0. And third point minus 2 by 3 pi. Please note that this minus 2 by 3 pi is just, so this is f of minus 2 by 3 pi is same as sine of 1 upon minus 2 by 3 pi, and that is same as sine of minus 3 pi by 2, and sine of minus 3 pi by 2 is 1 here, so it is 1. Similarly, minus 2 by 4 pi will be equal to 0. Similarly, minus 2 by 5 pi equals minus 1. Minus 2 by 6 pi, that's equal to 0. And similarly, we can have minus 2 by 7 pi. That will be equal to 1. So, from this side, we have to take points which are close to 0 but to the left of 0, and we have note all the function values, and from this side we have taken points which are to the right of 0 but close to 0, and we have note all those function values. In the previous videos, what we used to see is that if this was 1 by 1.9, this was then 1.99, this was 1.999, this was 1.9999, and so on. So as we were going close to some point, this f of x was going close to some other point. But here what we see is that this is 1, this is 0, this is then minus 1, this is again 0, this is 1, this is 0, this is minus 1. So it will go on oscillating from 1, 0, minus 1 back to 0, 1, 0, minus 1, and so on. So as x moves close to 0, the function f(x) is not sticking to on one point. It is not approaching to one point, but instead it is oscillating from 1, 0, minus 1 to 0, 1, 0, minus 1, and so on. If we look at the graph of this function, let me go a bit down. Let me have under coordinate system here. If we look at the graph of this function, its graph will be something like this. Although I'm not able to make it perfectly, but it will be something like this. So this will be here 1, and this is minus 1. From here it goes smoothly, and here it goes smoothly, but near 0 it will be oscillating from 1, 0, minus 1 to 0, 1, minus 1, and so on. So it will not be sticking to one point, but oscillating up and down, up and down, up and down. In order to see it clearly, let us see its graph. This is its graph. So this actually its graph. It is smooth from here, and then it oscillates, and its oscillation increases as we go close to 0, and then it decreases, and then is again smooth from some stage onwards. Let me zoom it a bit. So here you see the oscillation is very much small. The lines are very much close to each other. So near 0, the function does not stick to one point. So what we saw that, from this what we saw that, even if the limit is even if the function behaves finitely, it is not infinite, there is no jump, there is no gap, and there is no abrupt rise or abrupt fall, but still the limit of a function may not exist, and the case will be when there will be an oscillation, when the function will not stick to one point. As a next example, you can check at home f(x) equals cos of 1 by x, where x is not equal to 0 and x belongs to R. This will be same as we did earlier. So that's it for this video. Thank you for watching this. Please note that we have not discussed any technique for solving limit tests, but instead, in all the previous videos, we were focusing just on the definition of limit tests. In the next videos, besides discussing continuity, we shall also be discussing different techniques for solving limit tests. For more such videos, please subscribe to my channel and hit the like button. Thank you once again.